Today our topic is inverse of a matrix. Previously we have discussed adjoint of a matrix. Related to this one, we are interested to see inverse of a matrix. Write it for this one. Let A be a square matrix. Note down this one. Let A be a square matrix such that determinant A is not equals to 0. A be a square matrix such that determinant A is not equals to 0. Then A inverse is equals to 1 upon determinant A into adjoint of A. This is a formula to find inverse of a matrix. The condition is determinant A is not equals to 0. If determinant A is 0, then 1 upon 0 means infinity. So this is the condition for inverse. Determinant A is not equals to 0, then A inverse exists. Okay. So we can take an example of it. How will you find the A inverse? So write a question based on it. For example, I am taking a matrix of order 2 by 2 first. Okay. Find A inverse if A equals to, I am writing the matrix, A equals to it is 3 1 and 4 2. Order is 2 by 2. As I told you, the condition is it must be a square matrix. Now, first what I will do, I will find the determinant of this matrix. Okay, I am writing it. Det A for solution. First I will find determinant A. The meaning is this one. That is, this will be 3 1 4 2. Order is 2 by 2. 3 multiplied by 2, 6 minus 4, which is equals to 2, which is not equals to 0. Therefore, A inverse exists. Okay. Whenever they are asking about it, find A inverse. So you first find determinant A, and then you are saying what? If determinant A is not coming 0, it is singular, non-singular one. Then you say A inverse exists. Okay, this one is non-singular one. Then you say that what? A inverse exists. Okay, if it is singular one, means it is equals to 0. Then A inverse does not exist. If this one is coming as 0, then A inverse does not exist. Now you write it. A inverse is equals to write the formula 1 upon determinant A into adjoint of A. 1 upon determinant A into adjoint of A, and which is equals to 1 upon 2 adjoint of this one A. Adjoint of A is A11, A12, A21, A22. Directly I have taken transpose of this one. Previously I have done it. That is A11, A12, A21, A22 transpose of this one. Now here I have taken it. I am reducing one step and I am writing A11, A12, A21, A22. Directly we find it. Okay. Only when we are doing anything directly, just be cautious about it. So see here, I am finding A11. Removing this one. Now I am finding A11. A11 means it is cofactor. Cofactor of the element A11 of this determinant. Okay. So now I am finding A11. So see here, what is A11? A11, that is the positive part. See here, it is deleting this one. A11 means here I am calculating by means of identity minus 1 to the power I plus j. You know this thing, cofactor. Writing here Aij, I plus j, Mij. This is the formula to find cofactor. This one is cofactor. This one cofactor. A11, A12, A21, and A22. Here I am finding cofactor. So first I am finding A11. A11 means it is minus 1 to the power 1 plus 1, so it is 2, M11. Okay. This will be equals to how much? It is minus 1 to the power 2, it is positive 1. M11 means minor. How will you find the minor? M11, this one, deleting this row and this column where this element lie, and it is how much? 2. It is 2. So M11 is 2, minus 1 to the power 2 is a positive 1. Therefore, A11 is coming as 2. Now I will find A12. A12. Again I am using the identity. It is minus 1 to the power 1 plus 2, M12. Minus 1 to the power 3, that is minus M12. M12 means first row, element of first row and second column. So first row is this one, second column is first column and second column. That is deleting this row and this column, and you are getting minor of this one. It is 4. So it is minus 4. So in place of A12, I am writing minus 4. Then I am finding A21. A21 is equals to minus 1 to the power 2 plus 1, that is 3, M21. Minus 1 to the power 3, the meaning is it is minus M21. Don't upset with this one. M21 means deleting this one, second row and first column. Deleting this second row, this is first row, this is second row, deleting second row and first column. What you are getting? 1. This is 1. So A21 is minus 1. Now find A22. So see here, A22 means, see here, cofactor of A22. That is deleting this row and this column. What you are getting? 3. Write it here, A22, that is minus 1 to the power 4, M22, that is positive 1, and M22, that is, this one is minor of this one, is 3. Therefore, A22 is 3. Okay. So now A inverse is equals to, how much it is? Therefore, A inverse is equals to 1 upon determinant A into 2 minus 1, get rid of this one, 2 minus 1 minus 4, 3. On simplifying, we are getting 1 by 2, I multiplied it, which is 1 minus 1 by 2 minus 2 and 3 by 2. This one is A inverse. So A inverse is 1 minus 1 by 2 minus 2 and 3 by 2. So in this way, a matrix of order 2 by 2, you can find its determinant in this manner. Okay, clear it is? Now, we are interested to do a question based on it and write the question. If A is equals to matrix 2 by 2, it is 3 minus 4 minus 1 2. Find a matrix B. Find a matrix B such that AB is equals to I, that is identity matrix. Okay. Now, since I want to use the concept of inverse, okay, the topic which we have seen, I want to use it in this question. Okay. So now what I will do? First, I will find the determinant of this matrix. Determinant A. 3 minus 4 minus 1 2. Note down this. We are getting 3 minus 4 minus 1 and 2. Determinant, remember it, 2 vertical lines you will use. This will be 6 minus into minus plus, and minus is there, so minus 4, which is equals to, again it is coming 2, which is not equals to 0. Therefore, A inverse exists. Okay, since determinant A is not equals to 0, it is coming 2, which is not equals to 0. Therefore, write it, A inverse exists. Now, what is given to us? This is given to us, AB is equals to I. This one is given to us, AB is equals to I. I am multiplying, some algebra I am using here. I am multiplying both the sides by means of A inverse. This is given, you write it here given. Here you write it, multiply A inverse, meaning is both the sides. When you are multiplying it, you are getting A inverse A into B is equals to A inverse identity matrix, that is 1. Alright? A inverse into A, this one is I. By the property A inverse into A is I into B is equals to A inverse. Therefore, B is equals to, again identity matrix, therefore B is equals to A inverse. Means if we find A inverse, this is our matrix B. So that is the question they have asked it in a different manner. Okay, the question they have asked it this one. There we are using what the concept we have seen it inverse, and see it with the help of inverse. If we find A inverse, then automatically you will get the matrix B. Alright, so now what I will do, I will find A inverse. In order to find A inverse, what I will do, write it. A inverse is equals to, by formula, A inverse is equals to 1 upon determinant A into adjoint of A, or which is equals to 1 upon determinant A, what we find 2, and adjoint of A, directly I am writing A11, A12, A21, A22. This one I am writing. As I told you, directly I have taken transpose, okay, so that we are free from one step, okay, one step, no need to write it direct, but when we are doing anything directly, you must be cautious, remember it. Now, only we have to find what? A inverse. This A inverse is matrix B, okay. Now, I am finding this one, A11, A12, A21, A22. Okay. Now see here, A11. Previously I have find it, therefore I will not write it. I will do it directly. A inverse is equals to 1 by 2. Matrix A11 means cofactor of this one. A11. Deleting this row and this column. One more thing I want to say, you try to remember it whenever you are finding the cofactor. This is A11 positive, A12 it is negative, A21 negative, positive, positive, negative, negative, positive in 2 by 2. If it is 3 by 3, like this, plus, minus, plus, minus, plus, minus, plus, minus, plus, like this. Okay. So similarly, this one is a positive one, first one, A11, therefore it is positive. Deleting this row and this column, minor, it is 2. See here, this is 2. Previously we have done in adjoint of A inverse, previously we have find it. Now, A12, first row and second column, cofactor of this one. So now, deleting this row and this column, what you are getting? Minus 1. Where you will write? Minus 1 here, because it is A12. The third one is A21. A21, second row, first row, second row, and first column. Deleting this row and this column, what you are getting? Minus 4. But as I told you, this one is of which sign? Negative sign. Minus and minus become plus. Okay. What about this one, A12? This one is A12 means here it is also minus, so therefore minus and minus it will become plus. Here, when I take this one, it is minus 4. Again, because of minus sign, it becomes plus 4. The next thing is 2, A22. Okay, positive or negative, positive 1. Deleting this row and this column, it is 3. So this one is coming as A inverse is coming as 1, 2, 4, 1, 3. Simplified further, what you are getting, this will be on multiplying by 1 by 2, you are getting 1, 2, 1 by 2 and 3 by 2. So therefore, our matrix B is how much it is? It is A inverse. So therefore, matrix B is equals to 1, 2, 1 by 2, 3 by 2. This is the required solution. Clear it is? In this way, we have used the inverse to find a matrix. And which type? What the condition given? AB is equals to identity matrix. That is the product of these two is an identity. That is 1. Means A is the inverse of B or B is the inverse of A. A is inverse of B or B is inverse of A. Like this. But here A is given to us and we have to find B. It means B is inverse of A because identity is here. Okay. So here we have seen it, the inverse of a matrix. Okay. Now next time you try this one to find the inverse of a matrix of order 3 by 2 as a work for you. Okay. Here it is. Thank you.